Hi, my name is Ron Dorn. I'm a physical geography professor at Arizona State University. And the purpose of this presentation is to walk you through the start of the Hawaii lab stage 0. The thinking is that this is the very first exposure you're going to have to doing a GPH112 lab, and I want to show you my perspective on hopefully how to make it fun and interesting and reduce a little bit of stress. Keep in mind, I'm old. You can see me. I'm a 62-year-old professor. I don't play video games, but we think that we being Ryan Heintzman and I and others who helped develop this course, think it's the best way for you to really be exposed to physical geography. And so I'm going to assume that you downloaded the game successfully and installed it on your computer. If you have problems with that process, this is not the video. The idea would be for you to get help by other resources on the Canvas website, or for you to contact your instructor for a Zoom tutorial session to help you out. So I'm going to start sharing the screen. And what I have here on my Big Mac computer that you can hopefully see is the Hawaii game. I decreased the size of the game so you can see that and the PDF file on the same screen. The idea here is that you want to be able to use the PDF file either as a printout or on your device as a separate device. It's unlikely you'll have a big screen like this, but if you do, that's great. So I'm assuming you've never played the game before. One of the tricks to do the game is to hit the escape button that takes you into the mode where you can click on the different layers of the game: rainfall, dew point, and the Landsat overview on the digital elevation model, the topography. And if you click escape again, that puts you in the game environment where if you move your mouse and if you move the scroll of your mouse, you can zoom out to get a different camera angle, or you can zoom in. It's just like playing a real video game. You can actually plug your controller in if you're a video game player, but you probably don't need this video if you are. And you can change the camera angle to get an overview of what you're seeing on the Hawai'i volcano and how you're looking at Mauna Kea in the distance. You may hear your game heating up your computer. That happens with my computer. The Hawaii game is the worst of all the games in terms of making your processor work. The reason is that you are seeing the topography and the real scientific data displayed at a 30-meter resolution. That takes a large amount of processing power. This is real physical geography that your computer is doing and interpreting, and it takes about 7 minutes typically for your computer to load everything down, and then the heat load will drop, and then your fan should be able to handle it. Um, you should have a 4 GB RAM computer. It helps if you have a video game card on your computer. The Hawaii game, again, is the worst of all of them in terms of the processing load that it has on your computer. So let me orient you a little bit to what you're seeing. There is an inset map here where you can see the key locations that's plugged into the fast travel in the game environment. So for example, I'm going to go to the menu here, this little triangle here, open it up, click on fast travel, and I'm going to go to the top of the Mauna Kea volcano. The game starts on the Kohala volcano. So I click on Mauna Kea volcano, I close the window, and I am right here on top of Mauna Kea. So I'm going to zoom in on the inset map to the top of Mauna Kea, and my avatar, I took it off of escape and now I'm zooming in. My avatar is looking. See how the view of the directional indicator? So the avatar looks in one direction and then the camera angle looks in another direction. You're given a complicated display that I hope is not too complicated. The outer ring displays the camera angle. So this little barb is pointing to the south, and the camera angle is looking to the south, and you know this from the outer compass ring. The inner compass ring is what the avatar is looking at. So I'm going to change what the avatar is looking at. The avatar is opposite of the camera angle. The avatar is looking in the direction of the inner ring, or at north. You're getting the digital readout of elevation, longitude, latitude, dew point, and rainfall. I explained in another video how you can change the color ramps of the different bits of information of how dew point is displayed or how rainfall is displayed. I won't do that here. What I want to do is to show you how I would approach this game in stage 0. I would have read the PDF file in advance that goes over the lab title, the major volcanoes, how to download the video game, how to install the video game, how to practice the video game, how to change the color displays. My suggestion is that you put this PDF on a second device or print it out, and that you get out a pencil and some kind of paper to take notes. The idea is that you can take notes on what you're doing and completing the lab, get the instruction in the PDF file, and actually play the game. If you have a youngster around your house who plays video games, certainly recruit them to do the game playing while you take notes, and hopefully they can learn a bit of academic vocabulary and help you out in the process. And also learn about a college RAM. So I recommend you go through the steps in this PDF file of practicing the game. There's information on your computer heating up, and then you get the questions that you will actually see in the canvas. So stage 0, the questions you see in this PDF file are identical to what you see in Canvas, including the potential answers. So in Canvas, for question 1, when the game starts up, spin the camera angle so that you're looking at the avatar's face. So I'm going to have to simulate with the game starting up by plopping you on Kohala volcano with the Landsat layer. And when the game starts up, the avatar is not facing south, it's facing a particular direction. But what I want to walk you through is not the first question that the camera angle is facing in the avatar, because I explained that already. It's the latitude, longitude, and elevation readout. Notice that your choices are slightly different. You can tell the difference between these in terms of the order. Latitude should come first, longitude should come second. The dew point reading is slightly different because we jumped to the Kohala volcano via fast travel. It should be 52 degrees Fahrenheit. The rainfall should be 2157. We jumped to a slightly different location. And the location of the avatar in the inset map here should be the Kohala volcano. And it is the Kohala volcano. The idea is that you find the avatar on the inset map and you can identify the volcano that way. Question 2 that I'll walk you through is learning how to teleport, walk, jump, and study the elevation of river erosion and vacation. So the question 2 first asked you to go to Google Street Views via this link to the Pololu Trail. Sorry, I messed things up. All right, so I'm copying and pasting the Google Street View on the Pololu Trail in the Pololu Valley. And I'm virtually hiking down into the Pololu Valley. And then there's another link here that takes you to a YouTube video that should eventually play about a drone footage that you can see in the Pololu Valley. So here's the YouTube view. And so the idea is to give you a sense of place of either Google Street Views or drone views of what you're actually seeing in the game environment. So then the instructions are to use fast travel to enter the latitude of 20.1998 and longitude minus 155.7382. Click on fast travel and I get plopped down. What I'm doing is in the game mode, I'm using the scroll bar on my mouse to step back and see what's going on. So I'm in the Landsat view where I'm at an elevation of 215 meters, dew point of 66 degrees, and a rainfall of 2149 at this particular location. So my job is to, in this question, is to finish filling out a chart by getting used to looking at data and comparing elevation in the map. So the idea here is that I want to go to the Pololu Valley at this location and compare the elevation of where I am up high at 215 meters. And then in the game mode, I'm going to move the avatar down to the bottom of the valley. I'm at 35 meters. So I want to jump back up there. I have to hit the space bar. Oop, I didn't make it. I hit the space bar at the same time as the arrow key, and I'm back up there. So I've looked at the ISO Hyatt 2149 and then compared the elevation up on the ridge of the original elevation of the Kohala volcano to this valley that's being deeply incised into the Kohala volcano, the Pololu Valley. So by subtracting 35 from 215 meters, the depth of the valley is 180 meters. So the instructions in finishing out the chart are to practice going up the Pololu Valley and noting the elevations when I reach different isoheights. So I'm going to jump down to the valley bottom here, and the instructions are for me to go to the 2823 millimeter isoheight. So I'm at 2823 at this particular location. I'm zooming into the avatar here. I'm down on the bottom of the river valley, and I'm at 2823, and the elevation is 94 meters in the bottom of the river valley. So my task now is to jump up above this location of 94 meters, if I can. If I can't, then I'm gonna do one of two ways. I either move back down the valley and get enough momentum on my avatar. I'm not very good at this. Okay, avatar, jump. Ah, didn't make it. I need some momentum. Takes practice, and I'm not very good at it. You'll get much better than I am. So the reason for the steps is that that's the digital elevation data. That's the way geographers access and use data. It exists in 30-meter increments in this point, or 10-meter increments. We rarely have better elevation than 10 meters without using things like drones and terrestrial laser scanning. But this is a big employment field in geography. So now I'm up on the ridge above where it was 23 millimeters and 94 meters, and the elevation is 455. Ah, I forgot what the bottom elevation is. So remember 455, jump down to the bottom, whee, and it was 95. 455, 95. That's 460 meters of the depth of the valley at this location, 460 meters. So the task is to look at the isohyets, measure the elevations above and below, figure out the valley depth, and then in question 2, answer the question, what is the average depth of the Palulu River Valley by measuring the valley depths at about the location of the isohyets, 2150, 2800, 3200, and 3500 millimeters of rainfall, and then calculate the average. Notice that the choices are quite different. They're 40 meters or more different. So you don't have to be paranoid about the exact precision of the elevations or the average, because when you do it, you just pick the closest answer. And the beauty of stage 0 from an introductory perspective is that when you enter your answers on Canvas, you will get the feedback and you'll see what the correct answer should have been. And only in stage 0, you can go back and retake the quiz. The idea is for you to have low stress, learn how to play the video game. Don't rush through it. Get comfortable, especially in the Hawaii lab, with you playing the video game, learning how to work it, how to do the problems efficiently. And then you can retake the quiz and get 100% correct and all the points. I hope you have fun with this lab. I hope you relax, and don't hesitate to contact your instructor if you have any issues. We can try and use Zoom to help tutor you, and there should be a lot of opportunities for you to get help. A laboratory course should take time. That's the rule from the Board of Regents. You're taking, even though it's 1 credit, it should be the equivalent of doing 15 weeks of laboratory in a chemistry or a physics or another lab science like biology. So we've designed these to be split out into stages. They will take time, but hopefully you'll relax, enjoy it, and appreciate physical geography and how science works. Have fun with this one and don't hesitate to ask questions. I hope the video helped you.